Hello, Miss Powerbead. Can you introduce yourself?
Hi everyone, I am a power bead. I am the cutting edge of the inductor industry.
The cutting edge, huh? Powerbead, can I trouble you to explain?
Guys, don't look at me like that. I'm a master who can handle high currents. For the most popular server applications, the inductance will generally be in the tens of nanohenries to hundreds of nanohenries range, just like me. The power bead is the best choice for this type of application. My biggest feature is my low inductance and high current, because I am made of a material called ferrite. Compared with the molded inductor next door, my DCR is small, and it doesn't change with my inductance value. So my efficiency is great, even under a heavy load.
I don't know that word. Ferrite, did you say? What is that?
Ferrite is mainly iron oxide. Then some manganese zinc material is mixed in as needed, and then sintered at high temperature. You know what ceramic is, right? That's how I was born. Like fine china.
Wow, it's no wonder power beads are such a high-value part compared to other types of inductors. Next, I'd like to ask, what is your main job in the circuit?
I have two very important jobs in a circuit: energy storage, from electrical energy to magnetic energy, and energy discharge, from magnetic energy to electrical energy. Because, suppressing current changes is my mission. I must protect my circuit and all its parts from sudden changes in current, which can be very harmful. As for how to do it, here is an example. There are many ramps on the highway. In order to control the traffic flow of the highway, the ramps will be opened or closed according to the situation. As for me, I will look at the lines. The amount of load determines how much current to let through. Otherwise, the current will come in all at once, and we will be overwhelmed.
Isn't that what you'd call security?
Well, that's not all I can do. In addition to the energy storage and energy discharge I mentioned earlier, I can also change voltage in a boost, buck, and buck boost circuit. I'm really quite talented.
You really can do it all. Your talents are non-stop.
It's good to see my hard work paying off. On top of all of that, I can also perform basic filtering. Filtering is like flattening a steep road for the circuit to drive on.
So, to put it simply, the power bead has three main functions: energy storage and release, changing the voltage, and filtering, right?
You are absolutely right. That's my job in a circuit.
Great. Thank you for giving us a basic understanding of a power bead. For the next part of the interview, we have collected some questions from the audience. Are you ready?
Of course. It's my pleasure. Let's get started.
Our first question here is from Mr. Morris from San Jose. He asks, there are so many parameters in a power bead specification that I get overwhelmed. ISAT and IRMS are both currents, so what's the difference? Where is it? The higher the current, the better, right?
Thank you for your question, Mr. Marks. I wish I lived in San Jose. With the same size and inductance, the higher the current, the better. But it is not easy to make the current higher. This is related to the core of the inductor. It is affected by size. Let me explain the difference between ISAT and IRMS. Listen, ISAT is saturation current, which represents the current at which the magnetic flux is saturated. Generally, the rule of thumb is when the inductance value drops by 20%. It sounds difficult to understand, so let me explain it in another way. All right. Imagine, generally speaking, don't we have energy when we are full? But as we eat more and more, we go from full of energy to a food coma. It's similar for me as a power bead. As for IRMS, it is called temperature rise current. That is, the current at which the temperature of the inductor body rises 40 degrees higher than the ambient temperature after adding current. We all know that the higher the temperature, the worse the working efficiency. So IRMS is also an important reference indicator.
So it sounds like the two values are related to work efficiently, mainly due to the different measurements being affected. ISAT is based on the inductance value, and IRMS is based on the temperature, right?
That's right. That's it.
Then I'm curious, why does ISAT change with the inductance in the spec, but IRMS doesn't?
Good question. As you summed up, the difference between the two specs is that ISAT is based on the inductance as the reference point. The smaller the inductance of the same series of products, the greater the ISAT. We usually reduce the permeability by increasing the air gap. To accurately control the inductance, this air gap has two major functions. The first is to reduce the magnetic permeability, as mentioned earlier, and the second is to increase the saturation current. Therefore, the air gap makes ISAT follow the inductance, the key to change. Do you understand? As for IRMS, the temperature rise is used as the reference point. The rise in temperature is related to the coil of the power bead, because the coil has resistance. When the current passes through the resistance, it will heat up. This is called the so-called thermal effect of the current. Basically, the DC resistance of the same series of products, that is DCR, will be the same. This is the reason why IRMS does not change with the inductance.
Ah, that makes sense now. Thank you for your explanation. You mentioned the so-called DCR just now. It just so happens that the second question is related to DCR. Micah from Hawaii asks the question, should the DCR be as high as possible, or should it be as low as possible?
DCR is the direct current, or DC, resistance. Generally, the lower the DCR, the better. After all, the lower the DCR, the slower the temperature rises. However, it may not be applicable in some special cases, such as using DCR for current sense.
Okay, the third question is from New York, a girl named Vivian. Her question is, the error of your inductance is so large that it's often more than 10%. Why is that?
Because the magnetic permeability of the core material in the inductor has a relatively large error, and the large application temperature range will also cause the error to increase. After all, temperature also affects the magnetic permeability.
Yes, I think the inductance tolerance of power beads in the industry usually ranges from 10% to 20%. Everyone should pay special attention to this point when choosing specifications. Next is the last question of the day. Sister Simon Rowe from North Carolina. She says, I know the main feature of the power bead is that it has a low inductance and a large current, but I've always been unclear about how small is small and how large is large. Why is the power bead not suitable for large inductances?
Basically, if a power bead exceeds 3 microhenries, it is not practical for use because the inductance will be easily saturated. But there are still some power beads with special structures or new materials that can overcome this limitation. After all, technology is improving all the time. The more you improve, the more environments you can handle.
You're right. With the continuous progress of science and technology, ITG has broken through the traditional framework and made a large amount of power bead products, so we can finally use the power bead in the applications of large inductance values. Because the power bead has the great advantage of low DCR, it can mitigate the problem of heat, which is really amazing. If you're interested in our products, you're welcome to message ITG's website or leave a comment on the interview. If you have any other questions you want to ask Miss Power Bead, please leave a message in the discussion area below. See you next time. Bye.
If you are interested in additional technical information or reviewing product data sheets, please visit our website at www.itg-electronics.com. Make sure you register to stay up to date on our latest products and innovations. Thank you for watching. Have a great day.